Hello grade 9s, this is Mr. Miller and welcome to lesson 8.4 on solving equations in, boy, we got lots of different forms here. Ax equals b plus cx, ax plus b equals cx plus d, a times brackets bx plus c, close brackets, equals d times brackets ex plus f. Whew, that's a lot of different forms. Wow. Anyways, so here are the steps to solving those linear equations. And just a note here that some equations may not require all of the following steps. It's really important to realize at this point that the methods that we had before of either using the method of inverses, which is just figure out what's being done to x and undo it in reverse order, and we also did a little bit of cross multiplication, that's not going to be enough, which is why we've got this whole big long list of steps that potentially we may need to take all of these steps. Some of them are going to be optional, some of them we won't really have much choice, we're going to have to use them. So anyways, let's take a look. Number one, I'm going to multiply both sides of the equation by the least common multiple of all the denominators, or by the power of 10 that will change all of the decimal numbers in the equation into integers. Well, guess what? I've already taught you that, so we're all set to go. Number two, we want to expand any brackets. So what that means is that you'll be using the distributive property. Step number three, you want to simplify both sides of the equation. And really, we did that in previous chapters, like in chapter 5, we learned how to simplify algebraic expressions. Things like collect like terms. That's not too difficult. Put the x's together, put the constant terms together. Step number 4, move all the variable terms to one side of the equation. Typically, people like to have the variables on the left side of the equation, so you end up with an answer like x equals and just a number. Move all the constant terms to the other side of the equation. So if you've decided to move all your variable terms to the left, then you have to move all your constant terms to the right. Constant terms are terms that don't have any variables in them. Step number 6, divide both sides of the equation by the coefficient of the variable. And of course, we know what a coefficient of the variable is. It's the number that's multiplying the variable out in front. So now let's get into the examples and we'll see how these steps get used. So in question number 1, we want to solve and check each of the following. First one, we've got 0.4x equals 5.58 minus 0.2x. Now, notice that we've got a single variable x, but it's located in more than one place in the equation, which means we can no longer use just the method of inverses to be able to solve this. We have to have another method. Now, in this particular example, I'm going to choose to use step number 1, multiply both sides of the equation by, and since we have some decimal numbers, we're going to multiply by a power of 10. That's going to change the decimal numbers into integers. So if we multiplied by 10, that would change 0.2 to 2. In order to change 5.58 to 558, we have to multiply by 100. So we're going to take 100 and multiply it on both sides of the equation. That will convert all of our numbers into integers. So first off, 100 times the left-hand side and 100 times the right-hand side. 100 times 0.4 is 40, so we've got 40x. You need to use the distributive property here, 100 times 5.58 and 100 times negative 0.2. By the way, that's what we mean by expand the brackets. We're using the distributive property and multiplying through the brackets. Step number 3 is to simplify both sides of the equation. So there's nothing you can do with the left-hand side of the equation, so it remains at 40x. But on the right-hand side of the equation, we can do 100 times 5.58 and leave it just as 558. 100 times 0.2x is going to be 20x. So there's no further simplification that can be done. The next thing we want to do is we want to move all the variable terms to one side of the equation. So my choice is to move the variables onto the left. I do that by adding 20x to both sides. What happens is that the 20x, or the negative 20x, which was on the right, disappears because negative 20x plus 20x is 0. We just have the 558 remaining. When we add 20x to the left side, we add it to the 40x for a total of 60x. Now step number 5 is not necessary because we already have the constant term on the right side of the equation. Here's the constant term, it doesn't have any variables in it, and it's already on the right hand side. So the last thing we do is we divide both sides of the equation by the coefficient of the variable. The coefficient of the variable here is 60. So dividing both sides by 60, we end up with x equals, if you simplify this to lowest terms, it'll be 93 over 10, or you can write that as a mixed fraction, 9 3/10, or you can write it as a decimal, because this is still an exact answer, 9.3. Now we finished the solve part, next we have to do a check. So to do our check, we're going to start with the original left-hand side of the equation, which is 0.4x. We're going to replace the x with what we think is the solution, 9.3, and we're going to calculate. Now we need to do the same thing with the right-hand side. The right-hand side of the equation originally was 5.58 minus 0.2x. We need to replace the x with 9.3, which we think is the solution, and then calculate. We notice that we have the left-hand side and right-hand side are equal to each other. Since the left-hand side and right-hand side are equal to each other, that means that x equals 9.3 is a valid solution for this equation. And that's it. Now we can move on to part B. In part B, we've got an equation with several denominators, 2, 3, and 6. The least common multiple between them is 6, which is why I'm going to multiply both sides of the equation by 6. So step number 1, multiplying both sides of the equation by the least common multiple of all the denominators is what we're doing here. The reason that we're doing that, we want to clear out the fractions. I had mentioned this before, it is an optional step, but I'm choosing to take it this time. So now I need to use the distributive property as I expand the brackets. I'm going to do 6 times x over 6 and 6 times negative 9 over 2. I'm also going to do 6 times the 2/3 x. So you can see that 6 is multiplied across all of the terms. Now I've written the 6 as 6 over 1 because it looks like multiplication of fractions. Now the next thing I'm going to do is some simplification. So there's a factor of 6 that divides out top and bottom here. And there's a factor of 2 that divides out here. We're left with 3 and 1. There's a factor of 3 that divides out here. We're left with 2 and 1. So now we're doing 1 times x, well that's just x, and 3 times 9, well that's just 27, and we've got 2 times 2x, well it's just 4x. So look at that. By taking that step number 1, multiplying both sides of the equation by the least common multiple of all the denominators, and by following through with expanding the brackets, we end up with an equation that no longer has any fractions involved. We've fully simplified everything. So we've also taken step number 3 here. Now we want to move all the variable terms to one side of the equation. Currently we have an x on the left and we have a 4x on the right. Now you can move all of the variables to the left hand side, but just for a change of pace, I thought I'd move everything to the right hand side of the equation. So I do that by subtracting x from both sides. Because what happens is that takes care of the x from the left, it's gone. X minus x is 0. The negative 27 is the only thing that remains there. And 4x minus x is 3x. So now we have an equation where the variable term is only on the right hand side. Step number 5, move all the constant terms to the other side of the equation. Well, we can see that we've got the variables on the right and we've already got the constant term on the left. So there's no need to take a step number 5. Step number 6 is to divide both sides of the equation by the coefficient of the variable. So that means we're going to divide both sides of the equation by 3. And that leaves you with x equals negative 9. So we have a solution, now we just have to check. So we start with the original left-hand side of the equation, replace x with what we think is a solution, and then calculate. Now it's a little bit complicated because it is involving a lot of fractions, right? Negative 9 over 6, if you're going to subtract 9 over 2, then what we need to do is we need to change the 9 over 2 into a fraction with a denominator of 6. That's why I multiply the top and the bottom here by 3. That way we get 27 over 6. Now doing negative 9 over 6 and taking away 27 over 6, I know that a lot of people tend to make mistakes of subtraction of signed numbers. So instead I wrote it as adding the opposite. And then you've just got negative 9 plus negative 27, which is negative 36 over 6, which reduces to negative 6. A lot of steps, and obviously once you plug in your numbers, you can actually just put it into your calculator and give me what your final answer is for what you've calculated for the left-hand side. That's fine. But it is a good idea to know how to do all of the operations with the fractions here. So now starting with the original right-hand side, which is 2x over 3, we're replacing the x with negative 9, which we think is the solution to this equation. Now if we do 2 times negative 9, that's negative 18, and divided by 3, we get negative 6. And notice that again we have left-hand side and right-hand side of the equation are equal, which means that x equals negative 9 is a valid solution for this equation. So now that we've practiced some checking, we're just going to work on doing the solving. You may still want to have your steps out in front of you and referring to those, but I'm just going to go ahead and proceed with solving these equations now without doing any formal checking. So the first equation, you notice, has got lots of denominators, and we could certainly multiply both sides of the equation by the least common multiple. But in this case, I've decided to skip step number 1, just to show you what it would look like if we didn't take that step. So I didn't multiply both sides of the equation by anything. I didn't have any simplifying I could do. What I need to do is I need to move all the variable terms to one side and the constant terms to the other side. So you can see I've added 1 to both sides of the equation. The reason that I've done that is because negative 1 plus 1 will be 0, and that means the constant term will be gone from the left. So effectively, I'm making the constant term appear on the right-hand side of the equation. So as a result, we end up with 1 3/4 on the right, and we don't have any constant term on the left anymore. I've already started to take the next step, which is to move the variable term to the left. So we had a quarter x here, and I'm going to subtract a quarter x. If I'm subtracting a quarter x from this side, I also have to subtract a quarter x from the other side. Now, in order to do that, I need to find a common denominator between 2 and 4, and of course that'd be 4. So I have to double the top and the bottom here. So changing it into 2/4 x minus quarter x allows me to go ahead and do that subtraction. And that just leaves me with a quarter x. Of course, on the other side of the equation, we had a quarter x minus quarter x, which is 0. We're just left with 1 3/4. So we're very close to having a solution here. So just moving over here, now we just have to divide both sides of the equation by the coefficient of the variable, which is a quarter. Of course, that takes a little bit of work because, first of all, we've got to change that 1 3/4 into 7/4. And then we've got to flip and multiply to get our solution, x equals 7. So now I went through that kind of quick, but hopefully by this time you're starting to get a little bit more comfortable with dealing with fractions. And if not, hopefully you will by the end of the unit, and we'll just try to get as much practice as possible with dealing with fractions. The next one, part B, we've got an equation which has some decimals in it, and I could certainly multiply both sides of the equation by 10 to get rid of those decimals. I've chosen, just for this example, to skip step number 1 and deal with the decimals as is. So I'm choosing to move the constant terms to the right hand side first. So removing this constant term from the left, I have to add 6.4, which means I have to add 6.4 to the other side. We end up with 5n equals 3n plus 9. Since I have a constant term only on the right, I want to have the variable terms on the left. So that means I need to subtract 3n from both sides. When I do that, I end up with 2n equals 9. Last thing, divide both sides by the coefficient of the variable, which is 2. And we end up with n equals 9 over 2, which is a fraction in lowest terms already. We can write it as a mixed fraction 4.5 or as a decimal 4.5, and that's still an exact answer. Now you may have noticed that I've done things in a little bit different order than is specified up at the top here. Notice that sometimes I'm moving all the variable terms to the left side of the equation, sometimes I'm moving them to the right. Sometimes I'm moving the constant terms to the right side of the equation, sometimes to the left. The main thing you need to realize is that variables need to go to one side, constant terms need to go to the other side. And 4 and 5 are really interchangeable. If you are going to take step 1, multiplying both sides of the equation by the least common multiple, or by the power of 10 that will change all the decimal numbers into integers, you should take that step first. And obviously expanding brackets and simplifying is a good thing to do next. But then those two steps, the 4 and 5, could definitely be interchanged. The last thing, dividing both sides of the equation by the coefficient of the variable, that should definitely be the last thing that you do. If it's even necessary to do it. Sometimes you already have a single x by itself without having to do that. So anyways, let's take a look at a few more examples here. In part C, we have m plus 1 over 2 equals m minus 2 over 5. And now the way I'm showing this work here is doing the cross multiplying as we did before. Another way to look at it is that we're multiplying both sides of the equation by 10, which is the least common multiple of 2 and 5. When you do 10 times m plus 1 over 2, you end up with a factor of 2 being divided out, and you just end up with 5 times m plus 1. Same thing happens on the right hand side. If you multiply by 10, there's a factor of 5 that would divide out, and you'd just be left with a 2 that multiplies to m minus 2. But anyways, I think most people can relate to the cross multiplying idea better, so we'll just keep using that. And once you've got it to that point, you've got some brackets, so you need to expand them. So distributive property, 5 times m and 5 times 1, 2 times m and 2 times negative 2. We can't do any more simplifying. Both sides of the equation are as simple as they can be. So we want to have all of the constant terms onto one side, so I've subtracted 5 from both sides to accomplish that. And I want to move the variable terms to the left-hand side, so I'm subtracting 2m from both sides to accomplish that. Now I have all the variables on the left and all the constants on the right. Last thing I need to do is divide both sides by the coefficient of the variable, which is 3, and we end up with the final solution, m equals negative 3. Now part D, this is the last one on this page. We've got another equation that's got some decimals to it. And I'm just going to deal with the decimals. And I'm going to go ahead and I'm going to expand the brackets. So I'm skipping step 1 and moving on to step 2. 0.3 times 2x and 0.3 times the negative 1. The negative 2.3 still stays there. Also, I do the 0.04 times x and I do 0.04 times 5. So that's also using the distributive property on the right side of the equation. So after I've expanded the brackets, I need to simplify things, tidy things up. So doing that multiplication, I get 0.6x and minus 0.3. And I still have negative 2.3 is another term here. You can see 0.04x and the 0.04 times 5 is 0.2. I can still simplify some more because notice that we have two like terms here. So negative 0.3 and negative 2.3, when you add those together, you get negative 2.6. Everything else in the equation stayed the same. So the next thing I'm going to do is I'm going to move the constant terms onto the right hand side. So we had a constant term negative 2.6. If we add 2.6, that makes this whole thing 0. But if I add 2.6 to the left, I have to add 2.6 to the right. So that means I'm going to end up with 2.8 as the constant term on the right. If the constant term is on the right, I want to have the variable terms on the left. So here's a variable term that's on the right, needs to move over to the left, where we need to get rid of it from this side. So I'm going to subtract that 0.04x from this side, and of course I have to do the same to the other side. 0.6 take away 0.04 gives me 0.56x, and of course this is gone from the side, we just have the constant term that remains. Last step here is divide both sides by the coefficient of the variable. We end up with x equals 5 as our final solution for this equation. Now, if you're not sure if you have the right solutions, remember that you can always use your calculator to check. So for instance, if I go to part C and I want to check that answer, I can simply plug in negative 3 for m plus 1, and we're going to divide by 2. That calculates the left-hand side of the equation. You can also calculate the right-hand side of the equation by doing negative 3, take away 2, and dividing that by 5. And again, I get negative 1. This shows that the left-hand side and right-hand side are equal for m equals negative 3, which means I have a valid solution. Just move this over and take a look at this one. If we want to check to see if x equals 5 is a valid solution for this equation, then what we can do is 0.3 times brackets 2 times x, and in place of x I'm going to use 5, take away 1, and subtracting 2.3. So that gives us 0.4 for the calculated value of the left-hand side of the equation when x is equal to 5. Let's do the same thing on the right-hand side. So we're doing 0.04 times x, which we think is supposed to be 5, plus 5, and that gives us 0.4. You can see the left-hand side of the equation and the right-hand side of the equation are equal when x is equal to 5, so therefore we do have a valid solution. Now let's move on to the next page. And we've got some problem solving to do. So the first one, we have the length of a rectangular garden is 1 meter more than 3 times the garden's width. If the perimeter of the garden is 34 meters, find its dimensions. So for this particular one, instead of writing a let statement, I'm going to draw a diagram. So I'm going to start by drawing a rectangle for the rectangular garden. We're told that the length is 1 meter more than 3 times the width. So why don't we start with the width? That seems like the simpler thing. The length will be adding 1 onto 1 meter more than 3 times the width. So 3w plus 1. Now that we've got something figured out for the dimensions using variables, we can set up an equation. We're told that the perimeter of the garden is 34 meters. Well, the perimeter is the distance around the outside of this object. So you're talking about adding all 4 sides together. So w is one of the sides, 3w plus 1 is the length, w is the other width, and 3w plus 1 is the other length. If you add all 4 side lengths together, you should get 34. Now it's a matter of solving the equation. So simplifying first, w plus 3w plus w plus 3w gives you a total of 8w, and 1 plus 1 is 2. Now we've got an 8w, a variable term on the left. There's no variable term on the right. So we've got a constant term on the right. Let's take the other constant term and move that to the right. So subtracting 2 from both sides, we end up with 8w equals 32. Last thing we need to do here is divide both sides by the coefficient of the variable, which is 8, and that gives us w equals 4. So now going back to the question, it's saying if the perimeter of the garden is 34 meters, find its dimensions. We know what the width is now, it's 4. The length is going to be 3 times 4 plus 1, so that'll be 13. So the dimensions of the garden are 4 meters by 13 meters. When they say dimensions, they mean find the width and the length, and we specify them with a multiplication symbol in between, and it's read as by, as in 4 meters by 13 meters. And that's it for that particular question. Let's take a look at the next one. It says in part B that the cash register in the school canteen contains a certain number of quarters, X, and a certain number of dimes, 30 minus X. So basically what we're saying is that if we've got, let's say, 1 quarter, then there are 29 dimes. That makes 30 coins in total. If there are 2 quarters, there are 28 dimes. That makes 30 coins in total. If there are 5 quarters, there are 25 dimes. That makes 30 coins in total. So notice that when we have 2 kinds of coins, if we have a total number of coins that we know, we can always say that there are X of one type of coin and the total minus X of the other type of coin. So that's just a little bit of advice for you as you're trying to do some questions in the textbook, because they're maybe not going to give away what X should be in your word problems. But since they've already declared what X is supposed to be representing, we don't have to write a let statement for this problem. All we have to do is use the fact that the total value of the coins is 585, and then we'll be able to determine how many of each kind of coin there are. So $5.85, we could use the 5.85, but why don't we just work in cents? Quarters, they're worth 25 cents. Dimes, they're worth 10. So I'm going to do 25 times X, and that'll be the total value of the quarters. 25 cents a piece times the number of quarters. And I'm going to add on 10 cents a piece for dimes times the number of dimes, and that'll be the total value of the dimes. If we add the total value of those 2 types of coins together, we're supposed to get 585 cents. That's $5.85, just written in cents. So there we have our equation. Now we have to solve the equation. You can see we've got some brackets here, so we need to expand the brackets. So it's 25x plus 10 times 30 is 300. 10 times negative x is negative 10x. Now we can simplify. So 25 minus 10x gives us 15x. Notice the plus 300 is still there, and the other side of the equation is still there. We've got the variable term 15x on the left, so we want to have the constant term on the right. So that means we're going to subtract 300 from both sides of the equation. We end up with 285 on the right. Last, we're going to divide both sides by the coefficient of the variable, which is 15, and we end up with x equals 19. So going back and rereading the question that says, how many of each kind of coin are there? Well, since there are 19 quarters, that means there are 11 dimes. Okay, so now on to part C. It says we've got plane A that leaves the airport. 1 hour later, plane B leaves the same airport on the same course. It catches up to plane A in 2.5 hours. The average speed of plane B is 300 kilometers per hour faster than plane A. We want to find the speed of each plane. Well, one little detail that when I did this distance, rate, and time question before, one detail that I gave you, one suggestion that I made was to make this distance, rate, and time chart. And of course, you know, rate means speed. But one thing I didn't tell you about was this handy little triangle that you can draw with distance, rate, and time in it. So if you can remember where distance, rate, and time go in this little triangle, then you can remember 3 formulas really. That distance is equal to rate times time. That rate is equal to, and rate is just another word for speed, rate is equal to distance over time and that time is distance over rate. So that may be helpful for you in trying to figure out how to do some of these questions if you've got those formulas very handily memorized in this one little memory aid triangle. In any case, when you're setting up this chart, it's good to start with things that are well known first. So, for instance, we know that plane A leaves the airport first, so it's in the air longer. Plane B is not in the air as long. It takes it 2.5 hours to catch up. So let's start with the time for plane B. It's in the air 2.5 hours, which it'll be easier to work with if we just change that to an improper fraction, 5/2. Now, since plane A left the airport first, and that was 1 hour before plane B left, that means that plane A is in the air for 3.5 hours. So changing that to an improper fraction is 7/2. Now, we don't know the speed of each plane. We do know that plane B is 300 kilometers per hour faster than plane A. So if plane A has a speed of x, then plane B has got to have a speed of x plus 300. Now, we don't know how far they go, but we do know that distance is equal to rate times time. It's equal to speed times time. So if we do speed times time, x times 7/2, that's going to be written as 7x/2. And to get the distance that plane B goes, we can do speed times time as well. So 5/2 times the sorry, I just lost it there for a second. Let's try that again. There we go. Got it back. So anyways, distance is equal to speed times time. So you're doing x plus 300 times 5/2, or multiplying in the opposite order. It doesn't really change anything. In any case, at that distance that they've traveled, they're supposed to meet up with each other, so these two distances should be equal, and that is the equation that we're going to use for this problem. Now, with this equation, it would be a good idea to multiply both sides by 2 first, because that clears out the fractions. That's a pretty easy one because the factor of 2 divides out. You're just left with 7x equals 5 times brackets x plus 300. Now we do have brackets, so it would be a good idea to expand on those brackets. 5 times x and 5 times 300, which gives us 1500. Now we've got a variable on the left and a variable on the right, and we've got a constant term on the right. There's only one constant term, it's on the right, let's leave it there. Let's take the variable term and we'll move it to the left. So to do that, we're going to subtract it from both sides of the equation. So 5x minus 5x is 0. 7x minus 5x gives us 2x. We've got 2x equals 1500. Dividing both sides by the coefficient of the variable, we get x equals 750. So now, just going back to read, what are we supposed to find? We're supposed to find the speed of each plane. Okay, well the speed of plane A is x, 750. Plane B is 300 more than that, so that's 1050. This plane's A speed is 750 kilometers per hour, and plane B's speed is 1050 kilometers per hour. And that concludes this lesson. I know that was quite a long one. We will spend quite a bit of time doing some problem solving, making sure that you're really comfortable with that, because I know that there's quite a few different types of problems that we could look to solve with equations, and I know solving equations themselves can be a little bit tricky, especially when you're dealing with decimals and fractions and all those things. So no need to worry, we are going to spend several classes just doing lots and lots of practice, and hopefully by the end of it you'll be feeling a heck of a lot better about it. And hopefully we can do some review and have just a fantastic test. Anyhow, thanks for hanging in there, watching the whole video. You guys have yourselves a lovely day. Bye-bye.